Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at. Welcome back. And for this video, we're going to be still reviewing quadrilaterals, but now we're specifically going to focus on square, okay, or squares and the properties of a square. So let's go ahead and jump on in. Now, just as a reminder, as I've done with the other videos, I just want to take a look at this chart here, okay? A square shares all of the characteristics of everything above it. The characteristics of a rectangle, the characteristics of a rhombus, the characteristics of a parallelogram, and the characteristics of a quadrilateral. A square is all of those things, okay? So we can check all of those characteristics off, and we still have to include the fact that a square, just going over it, is that it has 4 right angles and 4 congruent angles. 4 congruent sides. Now, so let's go ahead and fill this in. So as I said before, it has all of the characteristics of a parallelogram, a rectangle, and a rhombus. So we're essentially going to put a check in all of these. Okay. So all of these properties apply to a square. All right. Let's go ahead down and take a look at numbers 15 and 16. So here, let's go ahead and take a look at what they're asking us, and then we'll label different parts of our square, okay? For example, in number 15, it says if ZY equals 20, then find WV. Okay, so ZY is right here. Now, ZY is a side, just like any other. So in a square, we know that all sides are congruent. So we know that all the other sides are also 20. And they're asking us to find WV. So that's something totally different. WV. Now, WV is half of WY. So really, if we know what if we can figure out what WY is, then we can just divide that in 2, and that'll tell us what WV is. So this is let me put a right angle box here. So we're going to be looking at a right triangle. There's multiple ways to look at this to solve this, but the first way we're going to do this is by looking at this bigger right triangle. So I'm going to draw it out over here to kind of give everybody an idea of what we're looking at. This is W, this is Y, and this is Z. And we know that this is 20 and this is 20. And since this is a square, the other thing that we know about the square is that the diagonals bisect the angles, okay? Diagonals bisect opposite angles. So every angle, every corner is 90 degrees. Bisecting 90 is cutting 90 in half. So half of 90 is 45. So these smaller angles right here are really 45 degrees. So this is a 45, 45, 90 triangle, which means automatically now we know what the distance or the length of WY is, okay? So just to kind of go back over that, I'm going to draw another diagram here. So in a 45, 45, 90 triangle, you have a leg. Oops. Both the legs are congruent. Let me go back. Sorry about that. The legs are congruent. Okay, so this leg and that's a leg. Now the hypotenuse, which this is the hypotenuse. The hypotenuse is equal to the leg square root 2. Okay, that's just a given formula. So with that being said, if we know that the legs here, if this is a leg and that's a leg, then we know that the hypotenuse is equal to 20 square root 2. Now I'm going to erase all of that. And we know that WY, like I said before, to find WV, we have to, WV is half of WY. So let me write that out. WV is equal to 1/2 WY. Okay. Now, some people may be asking, why is that? Well, the diagonals of a square, they bisect each other. Okay. And remember, a square has all of these properties. So the diagonals bisect each other. So with that being known, that's why I'm using this concept here to say that WV is half of WY. So if I just take half of that, which this is what it would look like, WV is equal to 1/2 times 20 square root 2. Well, half of 20 is 10. So WV is equal to 10 square root 2. All right, so we would do 10 times 2 square root, and then we would say equals. So that right there, that would equal 14.1, roughly. So let me change my equal sign to an approximation, because there's a difference between these two answers. This is exact, and this answer here is an approximate or an estimate. Okay. If I wrote out all the decimals that were possible for this number here, then yes, that would be exact. But if I wrote out 2 to the hundredths or the thousandths place, it would still be an approximation. It'd be closer and closer to the exact, but it would still be an approximation. Now, with all that being said, so that's one way to go about solving this problem here. Okay. So we basically took a look at the larger, we basically took a look at this larger right triangle. Okay, that's the one that we take a look at to solve the problem the first time. Now, let's take a look at how another way that some other people may see this problem and solve it. Okay, so once again, we'll start off with ZY is 20. Okay. Now, we already know that the diagonals, they bisect each other and they're perpendicular. Okay. The diagonals, the diagonals are perpendicular. So perpendicular means they intersect to make 4 right angles. So right here, there's a right angle. Okay. And matter of fact, let's use another one. We'll use this one here, because we know all the sides are 20. This is 20, okay? Now, what we don't know is the distance, the 2 legs here, okay? And I'm going to actually use the same color because they're both the same. Whatever WV is the same as ZV. So we have a smaller right triangle that we're going to be looking at for this one here. We're going to be looking at this right triangle. So when I draw that, this is going to be 20, and that's Z, this is W, and this is V. Here's our right angle. We don't know these measurements here. However, we can use Pythagorean theorem to solve this. So that's another way we could go about doing that. We don't have to use the angle measures, the 45, 45, 90. We could, and we would still end up with the same answer, but let's go ahead and use the Pythagorean theorem. So this would be x squared plus x squared is equal to 20 squared. And from there, that's just 2x squared is equal to 400. You divide both sides by 2, that's going to give you x squared is equal to 200. And then you know x is equal to the square root of 200. Now we can break that down to say the square root of 100 times the square root of 2, which means that x is equal to 10 square root 2. And like we already did, we know that when we do 10 times the square root of 2, it's approximately 14.1. So that's another method that you could use to also, you still get the same answer. Whether you use the Pythagorean theorem or the 45-90 formulas, you'll still end up with the same answer here, okay? So let's go ahead and move on to number 16, and that will conclude this video. Now, number 16, they are giving us WYX. So let's highlight that angle, WYX. And that's this angle here, which we already know is 45 degrees. Even if they don't have to tell us, that's already understood, because this purple line that I'm highlighting here, that diagonal bisects the 90-degree angle, okay? All four corners are 90 degrees. So half of 90 is 45. So that's why WYX is 45 degrees, right? So now that we know that, we can go ahead and solve our equation here. We can simply say 13x minus 7 equals 45. Add 7 to both sides. That's going to give us 13x is equal to 52. Divide both sides by 13. X is going to equal 4. And we've solved our problem. Okay? All right, I hope this video helped clear some things up and help some of you all understand how to apply the properties of a square to solve a geometry problem or algebra problem. You all have a great day, and I'll see you all back later for another video lesson. Deuces.